Hey guys, so in advance of our first quiz, I figured, you know what? Maybe I will offer to do a video answer key of our review guide. I don't think I'm going to be able to do this all the time, but for our first quiz of the year, I thought I would help out. So here we go. All right. So in our first example, we have 10 minus negative 49, and it's just important for us to recognize that subtracting a number is equivalent to adding that number's additive inverse. So I think I would consider this instead as 10 plus positive 49, which I think makes this a much easier problem. I hope we can agree that our sum will be 59. All right, making moves. Very similar here. We're again subtracting a negative number, and I think what would be much easier is adding its additive inverse. So once again, we start with negative 10, and instead we're going to add 22. And maybe this is easy for you, but if you need a little visualization, here's a number line. I like to consider this problem as we start at negative 10 on the number line, and we are going to move 22 units to the right. That's what I think of as adding 22. I know that it's going to take us 10 units just to get to 0, and I think with the 12 additional units, we will make our way on to positive 12. So I think in this case, our sum is positive 12. All right, not so bad. All right. Negative 42 plus 49. You can think of this in the context of a number line. I also love to use the commutative property of addition to actually just rewrite this as 49 plus negative 42, or even more simply, 49 minus 42, also known as 7. All right. In 19 minus 43, this is a pretty tough example, and I really like to think of this in the context of a number line. So if I'm thinking of 19 minus 43, I kind of think that we start at the number 19, and subtracting 43, I think of as moving 43 units to the left on our number line. I know it's going to take us 19 units just to get back to 0, and the question is, how much further into the negatives are we going to go? Well, I think if we've taken 19 units to get back to 0, we just need to figure out how many are left. I'm going to do a quick 43 minus 19, also known as, 24. I think we're going to go 24 units further to the left on the number line. We're going to end up with negative 24 as our difference, if you will, as our answer. I think this has probably been the toughest problem so far, in my opinion. All right. It's important to recognize, we're not even there yet. Just a few more. Negative 87 plus negative 7. I'm going to rewrite this as negative 87 minus 7. I think we start at a negative number, and we go further into the negatives. We end up with negative 94. We get a larger negative number, if you will. And last but not least, I'm going to once again use the commutative property of addition to rewrite this as 93 plus negative 55, also known as 93 minus 55, which I think will give us, 38. All right, not so bad. When we're adding and subtracting more than just two numbers, like in examples 17 and 18, I think the best way to handle this is just to go left to right. So in this case, let's do 17 plus negative 11 first, which I hope we can agree is 6. And then we're just going to have minus 16 plus 17. I think once again, here it's really important. Let's take care of our first two numbers first. Let's combine 6 and negative 16 for a grand total of negative 10 plus 17. I think our final sum in this case is going to be 7. Similarly, in question number 8, let's just go from left to right. If we don't, we may find ourselves in a position where we've done things inaccurately. 25 minus 23, I think, is 2. And we're subtracting negative 15 and adding 21. I like to do just one thing at a time every time I write a new line. So I'm even going to take an extra line to rewrite this as instead adding 15 and then adding 21. I will say, while I always suggest going from left to right, when all we've got is addition going on, it's a lot fewer moving parts. It's going to be a lot simpler. You can just kind of add them all up. I think we get 17 plus 21, also known as 38. Awesome. So in this case, our final answer will be 38. All right, so that was our adding and subtracting positive and negative numbers kind of section. So I hope it's going well so far. Let's make our way on to multiplying and dividing. I hope we know that when we multiply a negative number by another negative number, we will end up with a positive product, in this case, positive 24. Let's see, in number 10, it's really important that we recognize whenever we have a fraction, that is how we're going to write division now. And I would read this as 35 divided by negative 7. And I hope we know that our quotient is definitely going to be negative, right? We've got a positive number being divided by a negative number. Our quotient is going to be negative 5. Awesome. Making moves. All right. Similarly here, all we have is, I kind of read this as -1 multiplied by the quotient of 8 and 40. And really, 8 divided by 40, you know, it's less than 1. You can think of it as a decimal or a fraction. I think the real favor we can do our readers is just to simplify that fraction as 1/5. So I think our eventual quotient is just -1/5. And that's it. I think this is a much easier piece of information for our readers to consume. All right. Similarly here, positive 24 divided by -6. All right. I think our quotient will be -4. Hope that's not so bad. All right. Now we got some sort of awkward problems where we have integers kind of interacting with fractions. And I know it can be a little bit tough because visually it's, well, awkward. In this case, for me, it's a lot easier to kind of work apples to apples. I like to consider this 24 over 1. So we really have in this case 24 over 1 being multiplied by, even though there's no operation explicitly stated there, we know that that's multiplication. Multiplied by -2/3. I know that our product is going to be negative because we have a positive number being multiplied by a -1. So we'll have a negative product. And I do know that our product will be, let's see, 24 times 2 is 48. 1 times 3 is 8. And I know that that is going to simplify to just -16. Awesome. Really easy to lose track of our negatives when we're dealing with these awkward fractions because we spend all of our, concentration on the fraction part. Don't forget those negatives. All right, making moves. -18 divided by -54. Well, we definitely know our product is going to be, our quotient is going to be positive, right? A negative number divided by a negative number. So I'm just going to even start by writing this as 18 over 54. And then in this case, this number is less than 1. Let's just reduce that fraction for our readers. 1/3. Boom. That's it. We're done. No need to write that as a decimal. I mean, it would be an infinitely repeating decimal, which I just don't think is nearly as clean as a fraction. Let's keep it as a fraction. All right. Once again, a little bit of an awkward situation where we have a fraction interacting with an integer. Let's write this 12 as 12 over 1, shall we? In which case we get 7 times 12 is 84. And 4 times 1, also known as 4. And this reduces to 21. Indeed, if you want, you are welcome to simplify, not cancel, simplify 12 and 4. Stylistically, I'd prefer that you write this again as 7 over 1 times 3 over 1. Instead of crossing these out or writing the new numbers there. It just gets a little bit too cluttered for me. This tells a much better story for our readers. You can draw their attention to the fact that you're reducing, but then write it again. Come on, we're in big boy and big girl math here. All right, making moves. I hope we know how to multiply fractions. All right, let's go ahead and do some simplifying. I'm going to go ahead and I'm going to simplify the 6 and 12 first. I'm going to rewrite our fractions as -1/5 multiplied by now, let's see, 70 over 2. I'm going to go ahead and reduce 70 over 2 to 35 over 1. And heck, if you really want, you can go ahead and simplify some more. 35 and the 5. Those will reduce to -1 over 1, also known as 1, times 7 over 1. Hey, look at that, -7. With all of that reduction and simplifying going on, we never even had to do any big multiplication. Our product in this case, -7. Life is good. All right. Aha, now I very intentionally wrote these problems this way because they look really awkward and confusing. Stylistically, I never, ever, ever use fraction bars that are anything other than totally horizontal. So visually, this is how I would have written it if I weren't typing, if I were writing it by hand. And this is awkward. I've got 3 divided by 4/5. And what I'm going to do to make life a little easier for myself is I'm going to just rewrite this 3 as 3 over 1. I think it just makes life a lot easier for me. And I hope we know how to do fraction division, right? If we're going to divide by the fraction 4/5, that is equivalent to multiplying by the multiplicative inverse of 4/5, namely 5/4. I think we end up with 15/4 as our answer. Stylistically, I'm down with improper fractions. Yes, is that 3 3/4? It is, but at this point we can assume our reader can find that out for themselves. This, I think, is the best response. And again, stylistically, we rarely use this symbol for division, but just I wanted to make sure we totally knew what was going on. So I used it here just to clarify. All right, let's see what we got going on. Another pretty awkward situation. Let's rewrite this as -7/8 over -3. Okay, note to self, I really want you to be aware that this number right there is equivalent to this number right here, is equivalent to this number right here, right? This numerator itself is definitely a negative number, right? 7 divided by 8 and times -1, or negative 7 divided by 8 or 7 divided by negative 8. I just want us to be really comfortable with that. So I just kind of like to put it out there. All right. Once again, I think it's a good idea to write our denominator as a fraction. We've got negative 7/8 divided by negative 3 over 1. So let's just write this instead as negative 7/8 multiplied by the multiplicative inverse. In this case, negative 1/3. I'm not seeing a whole lot of reducing we can do. I think we get 7 over 24. Note that we have a negative number multiplied by a negative number. Our product will be positive. Once again, with all these awkward fractions, easy to lose track of these negative signs. Just make sure we keep track of them. Just take your time. Take your time. All right. So that's it for our fraction component of this review guide. On to the distributive property. All right. Let's make moves. I would read this as 5 times the quantity of x plus 5, then plus 4x. So here we go. I hope you recall that if I'm going to multiply 5 by this number, x plus 5 is a number. It's formed by kind of having these two interact, but this is a number. And if I want to multiply that number by 5, I have to multiply both components by 5. So I think I'll have 5 times x plus 25 plus 4 times x. I think 5x plus 4x is equal to 9x. Right? I've got 5 x's here. I've got 4 more than there. I think I've got 9 in total. 9x plus 25. You're welcome to write that as 25 plus 9x. I'm okay with both. Phenomenal. All right. Now we got to be a little bit careful about our negatives. All right, negative 2 times negative 7 is positive 14. Negative 2 multiplied by positive 7r is negative 14 times r. And then we have this plus 1r, if you will. Sometimes it's really confusing when there's no coefficient, no number being multiplied by our variable. There's an implied 1 here. So I think I've got negative 14 r's plus 1r. I think that's going to be negative 13 r's to go along with our 14 from before. So this is our final expression. You are also welcome to write this as negative 13r plus 14. Either is okay by me. But this, I think, is a much simpler, easier, user-friendly kind of expression to give our readers. All right, hot damn. Let's make moves. Okay, in question 21, beware, beware, beware. The order of operations says that this multiplication right here between 5 and the quantity of negative 3 minus 7a, this multiplication has to happen before this addition. So do not add negative 9 and 5 first. Instead, we're going to have to distribute that 5. So we have negative 9 plus 5 times negative 3 is negative 15. And 5 times negative 7a is negative 35a. If you feel comfortable, you can have just gone right to negative 9 minus 15 minus 35a. And I think our final expression is just negative 24 minus 35a. Booyah. Awesome. All right. All right, so here's a tough part. And I think I'm just going to write in a little notation here, and I think it helps just kind of clarify what's going on. I'm just going to put a little plus there. I might even put it kind of in line. We rarely write this. I rarely write plus negative. I think it's kind of juvenile. But for me, it helps me remember what's going on here. I like to think of this as 5x and then negative 5 times this quantity. So remember, we are multiplying this number, 7x plus 4, we are multiplying this by negative 5. That's really, really important. So I think in this case, we're going to end up with 5x plus, okay, what's negative 5 multiplied by 7x? That's negative 35x. Plus, okay, what else? Negative 5 times 4, I think, is negative 20. And while I might not necessarily write this all the time, this is always what I think, and it really helps me. 5x, plus negative 35x, I think is negative 30 times x, and then just minus 20. And we're done. It's just, as you can imagine, anytime we have this negative number that's going to be distributed, it's so easy to lose track of what's going on and mess up our sign. So that's like a really big focus for me. And I want to make sure we're rock solid on it. So here's a great example. I'm going to just write in that little plus here just to remind myself of what's going on. So I think our next line should read 7 plus something else, right? We're going to be distributing this negative 2, and we're going to have two kind of mini products, if you will. Negative 2 multiplied by 10m, that's not so bad. That is negative 20m. It is really easy to lose track of this on this next line, though. Negative 2 times negative 9 is, positive 18. Aha! Very easy to lose track of the fact that we're actually going to end up with positive 18 here. 7 plus 18 is 25, and then minus 20m. All right. One more for the distributive property. Aha! Similar idea. So I've got negative 9a plus something else. Negative 5 times a is negative 5a. Negative 5 times 1 is negative 5. So our final expression should be negative 14 times a minus 5, right? In our last line, we no longer will write plus negative 5. We're trying to give our reader something super clean, super succinct, super easy to work with. All right, so that was the distributive property. On to exponents. All right, in our first example, because negative 2 is in parentheses, this expression says take negative 2 and take that number and multiply it by itself 2 times. Negative 2 is our base here. Negative 2 times negative 2 is definitely 4. Awesome. Versus in our next example, oh, note that we don't have a set of parentheses here. And in fact, this lingering negative means I would read this as negative 1 multiplied by 3 squared. Our base in this case is actually 3. The number being multiplied by itself is 3. We know 3 to the second power is 9. Negative 1 times 9 is negative 9. So really, really big difference between questions 25 and 26. And I want us to be super comfortable with that difference in notation and what it implies for our eventual answer. All right. 2/3 to the third power, well, that's 2/3 times 2/3 times 2/3. I hope you remember how to multiply our fractions. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Boom. There's our product. All right. Be careful here. I intentionally put this problem in. A lot of students will see two negative signs kind of in the same vicinity as one another, and they think, oh, they're going to kind of undo each other or even cancel each other out. Careful. One thing at a time. Remember, I'm going to read this as, considering that lingering negative as negative 1 times the quantity of negative 4 squared. All right, order of operation says we're going to do this exponent first. Negative 4 to the second power is definitely positive 16, which is going to be multiplied by negative 1. Our eventual answer is actually going to be negative 16. So be careful. If you had wrongfully thought that these two bad boys were going to kind of cancel each other out, you would be mistaken. So be very careful with that. Negative 5 to the third power, well, negative 5 times negative 5 times negative 5. I definitely know our product is going to be negative, because a negative times a negative would be positive, times a negative again would be negative. Our product is negative 125. All right, once again, you got to be really careful. Here we have a negative 1 being multiplied by negative 3/7 to the second power. All right, negative 3/7 to the second power. I'm going to kind of do some dirty work off to the side here. Negative 3/7 multiplied by negative 3/7. It's definitely going to be a positive product. 3 times 3 is 9. 7 times 7 is 49. All right. So what we have on our hands is negative 1 times 9/49, or 9 over 49, for a grand total of negative 9 over 49. All right, so once again, just got to be real careful with these negatives. Take it one step at a time. Are we on to roots? We're on to roots. This symbol right here means tell me the non-negative number that multiplies by itself to give 9. What is the principal square root of 9? That number is 3. There is another square root of 9. That's negative 3. But this symbol right here says tell me the non-negative square root. So in this case, we respond with just 3. All right. Here we are asked, negative 1 times the principal square root of 25. The principal square root of 25 is 5. Negative 1 times 5 is negative 5. So, right, remember how we said about each positive number has 2 square roots? This is how you would reference the negative square root as opposed to the principal square root. All right, in question number 33, we are asked to find the square root, the principal square root of negative 64, the number that multiplies by itself 2 times to give negative 64. That number is not negative 8. That number is not 8. That number is not real. It exists, and one day we will talk about it, but not in this class. Right now, we're just going to say not real. And anytime you try to take the square root of a negative number, so you have a negative radicand with a square root, this is going to be the case. Don't extrapolate any beyond that if we're taking a square root of a negative number, and I hope you can explain why that's the case. Versus the, check it out, the third root of negative 64. Is there a number that multiplies by itself 3 times to give negative 64? Yes, there is. It is a negative number, and that number is negative 4. Because negative 4 times negative 4 times negative 4 is indeed negative 64. Right, these two will yield positive 16, but when you multiply by negative 4 again, you're back in the negatives. So negative numbers do have third roots, or real third roots, that is. They just don't have real second or square roots. Making moves. Almost done. Aha. This is tough. A lot of negatives all over the place. Let's be careful. I'm going to read this as -1 multiplied by the third root of -27. The third root of -27 is -3, which we are then multiplying by -1. Our grand total in this case is 3. The third root of 8. Is there a number that multiplies by itself 3 times to give 8? That number is 2. 8 does have a very nice integer rational third root. That is lovely. That is lovely. All right. The principal square root of 9/4. Is there a number that multiplies by itself to give 9/4? Well, let's think about it. So I think we can agree that it's probably going to be a fraction. What number multiplied by itself gives 9? Yeah, that would be 3 times 3. What number multiplied by itself will give 4? Yeah, that's 2 times 2. So I think the principal square root of 9/4 is 3/2. Oops, excuse me. It's 3/2. Awesome. So, hey, even if you have fractions, look at this, a very nice, clean principal square root. All right, I love these particular types. We're trying to find the square root of 16/5. Once again, I think we can agree it's probably going to be a fraction. We're looking for a number that multiplies by itself to give, well, 16/5. So my first question is, what number multiplied by itself gives 16? That's not so bad. That number is 4. What number multiplies by itself to give 5? Well, it's not a very clean number. It's not a very easy number. It's not something like 2 or 3. But there is a number that does that. You know what that number is? By definition, it's the square root of 5. Right? That's what the square root of 5 does. It multiplies by itself, to give 5. Right? It doesn't do many other things well. It doesn't, cook well or, do athletics well. But it does multiply by itself to give 5. So the principal square root of that number would be 4 over the square root of 5. A little bit awkward, but hey, that's the best way we can express this number in a slightly simplified form. All right. The square root of 6 over 54. Ugh, kind of nasty, but wait, right? Because we're thinking, 6 is not a perfect square, and neither is 54. It's like, damn, that's even harder than the one that we had before. But can we reduce this fraction? Aha, we can reduce that fraction. 6 over 54, also known as 1/9, the square root of which is 1/3. So careful, I might throw you a curveball like this. Just got to be ready to improvise. All right, almost done. Aha, I love this. We're asked to evaluate, what is the square root of 11 squared? Well, what is the square root of 11? I don't know, 3 point something. It's not a very nice number. But I do know something about this number. And I know that, by definition, it is the number that if you square it, you get 11. And so if we're squaring it, well, we get 11. Right? Even though we don't necessarily have a strong grasp on what the kind of decimal equivalent of this number is, that's okay. We know that this is a number that if we square it, we get 11. So hey, that's what we end up with. Almost there. For the exact same reason, holy cow, what is the third root of -20? I don't know, -2 point something. But I do know that this is the number such that if I raise it to the third power, by definition, I'm going to get -20. So if we raise it to the third power, we get -20. That's all that number does. It really does almost nothing well. What it does do well is multiply by itself 3 times to give -20. And that's what we end up with. And similarly for this last example, I actually made a little typo here. Sorry about that. We are asked here, I love this example. Here we go, ready? This is great. 19 to the third power, also known as 19 times 19 times 19. This is a very interesting example. I don't know what 19 times 19 times 19 is. I probably could figure it out. Let's see if I can do this on my computer real quick. 19 times 19 times 19. 6,859. All right. 6,859. 859. Okay. So here's what it's asking. If we're trying to find the third root of this number, we're trying to find, what number multiplies by itself 3 times to give this? I don't know. Maybe 19, the number that we just multiplied by itself 3 times to get that. This question is saying, what number multiplies by itself 3 times to give 19 multiplied by itself 3 times? It seems kind of brutally obvious and a little kind of cyclical, but yeah, that's it, 19. What number multiplied by itself 3 times gives you 19 multiplied by itself 3 times? Yeah, that number is 19. So here concludes our kind of video answer key to our first review guide. I hope you found it helpful, and good luck, guys.